VLSos here. This is a video lesson on reciprocal trig. We're going to review the fundamental trig ratios first and then talk about their reciprocals. To do that, I'm going to draw a diagram of a right triangle. This is a right triangle because it contains a right angle. I'm using the right angle symbol, and opposite that right angle is the hypotenuse, which I'll label H. H for hypotenuse. I'm going to label an angle in this triangle theta. There are two sides that are next to theta, but since one of them is the hypotenuse, it's the other that we're going to call adjacent. I'll label it A for adjacent. The side opposite theta, I'm going to label with an O. And the letter O is a little problematic in mathematics because we're not quite sure when somebody writes it if they meant a 0 or an O. There's been an attempt to deal with that ambiguity by writing zeros with a slash through them. The problem is if the person meant to write a 0 and forgot to put a slash in it, then you'd think it was an O. So I am in the habit of putting a dot when I really mean the letter O. Technically, this is the symbol for circle, but it helps to see it. It's worth remembering the three-letter designation for the letters of the concepts hypotenuse, adjacent, and opposite. H is a single letter to stand for hypotenuse. We could also call it HYP for short. And of course what we mean is hypotenuse. A we typically use for adjacent. Three letters designation ADJ is seen often. And H of course, we already used H. O for opposite. I like to put a dot in it, or OPP and the full word opposite. We're going to be using the single letter designations when we write down our ratios. The fundamental trig ratios are sine, cosine, and tangent. So the sine of this angle is equal to a ratio of the sines. Sine is opposite over hypotenuse. O over H. Cosine adjacent over hypotenuse, and tangent opposite over adjacent. There are three sides to a triangle, and there are three fundamental ways to make ratios out of these, but there are three others that can be created if we simply take the reciprocals of these ratios. Reciprocal is switch numerator and denominator. We could take the reciprocal of sine and quite literally show it as 1 over sine of theta. And that would be equal to the ratio, sine's ratio, also if we take the reciprocal, H over O. But we have a special name for this ratio. It's distinct, it's different. It might be based on the same sides, but if we have measures for these sides, of course, and we take the reciprocal, they're not going to be equal value. So we have a name for this ratio, and that is cosecant, abbreviated CSC. Cosecant is the reciprocal of sine. Sine is the reciprocal of cosecant. We can do this with cosine as well. We can show the reciprocal of cosine as 1 over cosine of theta, or cosine theta's side ratio, we could take the reciprocal and get H over A. And that's a distinct reciprocal of sides. It has its own name, we call secant, abbreviated SEC. The tangent ratio, opposite over adjacent, we could take a reciprocal of, we get 1 over tangent, or adjacent over opposite, and that has its own name called cotangent. cotangent is the reciprocal of tangent. Tangent is the reciprocal of cotangent. And it's worth remembering that when we use reciprocals in our trigonometry, we're very often also going to make use of tangent can be defined as sine over cosine, which means that the reciprocal of cotangent can also be thought of as cosine over sine. Why is this useful? Let's give some examples. We could be given a problem, we can be given information in the form of a reciprocal. We could be given secant of an angle A that is unknown is equal to the ratio radical 13 over 3. How would we use it? Well, if this is unfamiliar to us, it would be worth it to draw a diagram and understand what it means to have the secant of an angle A equal to radical 13 over 3. So our diagram is going to begin with a right triangle. If we're using these trig ratios, just like sine, cosine, and tangent, they must come from a right triangle. So we'll label in our triangle diagram an angle and call it A. And then think, what is secant? Secant is the reciprocal of cosine. So this information is also, we can think of as 1 over the cosine of A. And if we think of the cosine ratio, the cosine ratio is A over H, so the secant reciprocal is H over A, which means that these values that were given are side lengths. Specifically, the radical 13 is the hypotenuse, and the 3 in the bottom of this ratio is the adjacent. We can label then in our diagram the adjacent measure of 3 to that angle A and the hypotenuse of radical 13. How does this help us? Well, if we use this information to identify two sides of the triangle, we can find and then label a third side with the Pythagorean theorem. The third side we're going to call O for opposite that angle A. In the Pythagorean theorem then, we have leg squared plus the other leg squared is equal to the hypotenuse squared. And a quick calculation, 13 minus 9 is the opposite squared, and 13 minus 9 is 4. So the opposite side must be equal to positive 2. We undid a square to get there, but in the Pythagorean theorem as applies to the sides of a triangle, a side can't be negative, so we only get the positive value for that opposite side. We've discovered the opposite side of this triangle. Let's give another example. We could be given the beginning information CSC, which stands for cosecant, of an angle. Now we have to be careful. Cosecant is a ratio, but this 3 pi over 4 is the angle that we're putting into the cosecant function. This isn't the ratio that cosecant is equal to. So this is not an equation, it's an expression. We could think of it as what is the ratio, what is the value cosecant of 3 pi over 4. So this is a problem of a very different nature, and how can we make sense of it? There's no cosecant key on a calculator. Well, most calculators don't have cosecant keys. A lot of calculators have sine, cosine, and tangent. Some only have sine and cosine. So we're going to convert this. We're going to think of cosecant as a reciprocal of sine. So we can express this as 1 over the sine of 3 pi over 4. And this, then, we can key into a calculator. So we'd use a calculator and literally type in 1 divided by the sine of 3 pi over 4. and a calculator would know how to produce that value, it would be the sine of 3 pi over 4 is radical 2 over 2. So the value is 1 over radical 2 over 2. Now how do we simplify something like this? It's worth including it in this lesson. When I have division inside of division, I typically then use the division symbol. What we mean is 1 divided by, then the fraction radical 2 divided by 2. This helps because when I see dividing by a fraction, I know I can convert it into multiplication and multiply by the reciprocal. So 1 divided by radical 2 over 2 is 1 times 2 over radical 2. And I can ignore the multiplying by 1. 2 over radical 2 is not simplified. We don't like radicals in the denominator. So what can I do to change it? I'm going to multiply by a version of 1, radical 2 over radical 2. And when I do, this becomes fraction multiplication. I get 2 times radical 2 over radical 2 times radical 2, or the square of a square root, which makes it 2. And these common factors can cancel out to give a final answer of radical 2. So we started with an unfamiliar trig ratio. We converted it into its reciprocal so that we could use the calculator key that a calculator would be likely to have, sine. And then we went through a process of simplifying that value.